So this video is for Dazzle Girl, who asked me on YouTube, can you please do a video on how to find the volume of a rectangular prism and one about how to find volume of solid figures? So just to let you know that solid figures are all these three-dimensional shapes we're looking at. So prisms are a type of solid figure. So we're going to be hitting volume and of solid figures as we look at the volume of these different prisms. Okay, so first one, let's start with the simplest example. It says find the volume of the rectangular prism, and we see over here when you look at a rectangular prism, what is it? It's basically just like what we think of as a box. Now, what makes it a prism is that it has bases that are the same shape on either side. So I know that because of the way we draw three-dimensional drawings, these don't look like rectangles. But basically, it's just because the angle we're at. What we have here on this prism is that we have identical rectangles on the top and the bottom. Both the base shapes are rectangles. And then we see all these other lines coming up at 90-degree angles from those bases. So that's what makes it a prism. Okay, two identical bases with the lines coming up at 90-degree angles to meet them. Okay, and so the really nice thing is anytime you have a prism, it's super, super easy. You can just find the area of the base shape. So I'm going to write this down. And don't worry, there's a formula for this, so you don't have to have this memorized. But I'll just let you know this is how students do it who don't have it memorized. All you have to do is find the area of the base shape. And multiply by this height of the prism. So like I said, on this particular prism, my base shape is a rectangle. It's super easy to find a rectangle's area. You might remember that whenever we did the area of a rectangle, we did length times width. So for the area of that base shape, it would be length times width. And now all we're doing now is adding a third dimension, height. And in fact, that's really all you have to do to find the volume of a rectangular prism. It's super easy. You just multiply the three dimensions, length times width times height. And in case you're thinking, it cannot be that simple. It sure is. If you were to look at the GED formula sheet for volume of a rectangle, I'm sorry. I broke English. Let me try again. If you were to look on the GED formula sheet for volume of a rectangular prism, it would tell you that the formula is to find area. Oh my land. I should have slept more last night, guys. To find volume, we're finding volume. We're going to multiply length times width times height. So literally, I will just multiply those three dimensions. And I don't care if you show me it in formula form or if you just know to multiply those three dimensions, you're going to get the same answer. But I am a mathematician. I speak in complete math sentences, so I'll put that V equals. So now V equals, and if I had this problem on the GED, I would definitely have my TI-30XS calculator. So I'm going to just type those things in. 15 times 3 times 8, and I get 360. And the question is 360 what? Well, remember, we're looking for volume. We're looking to fill this shape. You're not going to be able to fill it with lines, so it's not going to be a linear measurement. It's not going to be plain old inches. You're not going to be able to fill it with flat squares. If you want to fill space, and you want to measure volume, volume's always the filling of space, you're going to have to use cubic units. So whatever unit it is, like inches, is going to have a little 3 on it to specify that it's cubic inches. Now, be careful. This little 3, this floating exponent here, is not math I need to do. This is literally just me as a mathematician being too lazy to spell cubic inches, but I could have just as easily written that. It's just an abbreviation. Okay, so the volume of this solid is 360 cubic inches. Again, I just multiplied the three dimensions. Okay, so wonderful. Let's take a look at how this concept of prisms can get a little more complex. So on the next page, I have find the volume of the cylinder. So a lot of students say to me, Kate, why are we doing volume of a cylinder right now? I thought you told me we were doing prisms. And I got to say, like, this is a prism. Like, whether or not we call it a prism, I know we call it a cylinder, but take a look. A cylinder has a circle base. It has an identical circle base across from that. And then its height goes up from that at right angles. So just like we saw before, because this has the basic composition, even though it's got circles on either end, it's still got that basic composition of a prism. You're still going to find the volume. Volume's always found on a prism by multiplying the area of the base shape by the height. That's the consistent thing with prisms. Prisms are always area of base shape times height. So if you think about what is my base shape here, well, it's a circle. And if you were to look up the area of a circle formula, you would find out that the area of a circle formula is pi r squared. That's how you find the area of a circle. And then, of course, my height, if I call it h. So knowing this pattern, it's not going to surprise you that if you go to that GED formula sheet and look up the volume of a cylinder formula, you'll see this. Volume is equal to pi r squared h. The area of a circle times the height will give you the volume of that cylinder. And so let's plug in what we know here. And apparently when I was writing my questions, I left one of the numbers off my drawing. So excuse me, you guys will pretend like I never had this here. Good. Did you all pretend like I'm perfect and I didn't screw that up? Perfect. Okay, now let's plug in what we know here. So I'm plugging in for this volume formula. The first thing you have is the number pi. Remember that pi is not a variable. It doesn't change. It's a set number, but it's just an irrational number, a number whose decimal form goes on and on forever. I don't want to work with an irrational number. And so I'm going to use the approximation for pi, which is 3.14. So I just plugged in an approximation for pi, and technically I should use the wavy equal sign now since I started approximating. But 3.14 is close enough to pi, and it is on the GED formula sheet if you need it. Now, next thing I need to plug in is the radius. Remember that a radius goes from the center of a circle to its outside. They did give me the radius here. I hope you can still read it. It said 7 millimeters. So I'm going to plug in the 7 there. Notice that I plug in this middle number using parentheses. That's a good habit when you plug into an unfamiliar formula to use parentheses. And then I have this square here. And now I'm going to plug in the height. And the height of my prism is that line that drops from base to base at a 90-degree angle. So that's that 15 millimeters. And I'm way too lazy to do this math by hand. I'm going to just plug it into my calculator. 3.14 times 7 squared. And you might be thinking, Kate, don't I need to use order of operations? Yeah, you do if you're doing this by hand, but your GED calculator actually will do order of operations for you. So you can type in this expression exactly the way you see it, and it will take care of the order of operations. So I get 2,307.9, and it's 2,307.9 what? Well, again, your millimeters have got to be cubic because it's you're filling. You can imagine filling this shape with little bitty cubes stacked one on top of the other. It's cubic millimeters. Okay, great. So that's the answer on that one. Let's get a little more complex. Now, in this next example, it says find the volume of the triangular prism. And if you were to look on your GED formula sheet, you would be a little upset because there is no formula for a triangular prism on there. And so you might go, oh my gosh, why are they giving me this thing where we don't have a formula for it, and get really frustrated. But just to let you know, what they did instead is just give you this generic formula. They give you the right prism formula. So every single shape we've been looking at so far is actually technically a right prism. Again, the idea of a right prism is just those two matching bases with those heights that come up at right angles. And so this is a right prism. I have the two matching triangle bases. And I have these perfect 90-degree heights coming up from the bases. Okay, now just a reminder, like we had said, if we are doing, my phone is ringing and I got to turn down the volume. Sorry, guys. If we are doing volume of a right prism, you always can just take the area of the base shape and multiply by the height. And this is why students get stressed out when they look at the right prism formula. I want to show you what the right prism formula says on the GED. So if you were to look on the GED formula sheet for the area of a right prism, or the volume of a right prism, sorry, I keep trying to do that, but the volume of a right prism, you would see this formula. Volume is equal to, and then you'd see something interesting, capital B times H. And that is what that capital B stands for. It stands for the area of the base. Now, you might be thinking, well, darn, I'm out of luck. I don't know the area of this base. Well, remember that on the GED formula sheet, it tells you how to find the area of a triangle. It says that the area of a triangle is the same as 1/2 the triangle's base, little b base, times height. And so that b can be replaced with the area of a triangle. Now, this one's interesting, though, because this is the height. This h is the height of the triangle. And this is probably one of the most confusing things for students, but I still have this h, right? I replaced big B with the area of the triangle formula, but I still have this little h from before, and that h is the height of the prism, height of the prism. And so this looks really confusing to students. We have the same letter twice, meaning two different things. That just shouldn't be. And so I think the easiest way to work this formula is to find this B first. Let's go find the area of the triangle. So to find an area of a triangle, I do 1/2 the base of the triangle times the height of the triangle. So let's go look at our triangle down here. So I'm going to take 1/2 times the base of the triangle. That's a side length always, so that'll be 12. Times the height of a triangle. So the height is a little line that comes off of the base of the triangle to right angle, and I can see that that's 7 feet. And I'm going to just multiply that out, and you can do it in your GED calculator or you can do it in your head. But I know that 1/2 of 12 is 6, and 6 times 7 is 42, so I was able to do that in my head. So I just found the area of this shape. Now all I have to do to turn it into volume is multiply by the height of the prism. And so now to turn it into volume, I'm going to take the area of the base shape times the height of the prism, which is 23. And I just ran out of cool. I can't do that one in my head. So 42 times 23 gives me 966. And 966 what? Again, it's going to be cubic feet. Okay, so I feel like I might have over-explained that a little bit, made it a little too complicated. But again, anytime you're dealing with a right prism, you just find the area of the base shape and multiply by the height of the prism. Okay, one last one. Let's take a look. So again, we see find the volume of the prism. Find the volume of the prism. And again, we can see that we have this base shape here. Can you tell what it is in this case? See how we have the different labeling on either side of this shape? This side says 18 centimeters. This side says 10 centimeters. This is definitely a trapezoid. Okay, so if I want to find the volume of this prism, I'm going to have to take the area of a trapezoid and multiply by the height of the prism. Okay, so let's do that. How do you find the area of a trapezoid? Well, the area of a trapezoid formula is nasty. If you look at the GED formula sheet, it says that the area of the trapezoid is 1/2 of base 1 plus base 2, the sum of base 1 plus base 2, times the height. And again, I mean the height of the trapezoid because we're just looking at the trapezoid right now. Let's do that first, okay, before we get involved in anything else. So I have my 1/2. My two bases of the trapezoid are my parallel sides that are different lengths, so 10 and 18. And my height comes off the base at a right angle, so I can see that right there. That's 4. Okay, so I have 1/2, and I'm going to follow the order of operations and start inside a grouping of 28 times 4. Half of 28 is 14. Oh, I think I ran out of cool. I should be able to do 14 times 4 in my head, but since I keep screwing up today, I want to not mess up for you on camera. So I get that the area of this little shape here is going to be 56 square centimeters. But I don't want the area, I want the volume. So to remember, to find volume of a prism, you just find the area of the base shape and you multiply by the height. So now to find volume, I'm going to take the area of the base shape, that's how they write it on the formula sheet, times the height. So the area of my base shape I just found was 56, and my height here is 22 centimeters. And again, height in the volume formula means height of the prism. So up and down here, you can see it's labeled 22 centimeters. So 56 times 22 gives me 1,232. And 1,232 what? Again, it'd be cubic centimeters. So centimeters with a little floating 3. Well, hopefully I made that clear, Dazzle Girl. But if I didn't, feel free to ask me any questions. I know I kept messing up, but hopefully I did it well enough so that you get the idea here. Drop any questions you have in the comments, and be sure to let me know if there's anything else that you need help with.